Beneath the familiar plane of our solar system where planets trace their ancient paths lies a cosmic blind spot. A realm of profound darkness rarely observed, almost never explored. And from that abyssal depth right now, something colossal is rising. While our telescopes are fixated on a nimble interstellar visitor 3I Atlas, an object far, far larger has been stirring silently approaching from below. Its name is C2014 UN271, but the cosmic community knows it as Bernardinelli-Bernstein or BB. Imagine a chunk of primordial ice and rock nearly 150 kilometers wide, the size of a small moon or the distance between two major cities. This isn't just big, it's a giant relic from the very dawn of our sun. And here's the unsettling part: at a distance where it should be utterly frozen inert, a dead worldlet of ice it has begun to violently outgaze. Scientists are baffled. Is this merely a comet awakening far ahead of schedule? Or is something grander, more fundamental beginning to unfold out there? Something we're only just starting to perceive. Stay with me, because what comes next could reshape our understanding of everything we thought we knew. Astronomers across the globe are currently training their most powerful instruments on 3I Atlas, a fast-moving enigma hurtling through our system. Yet beneath this focused gaze, another far more massive entity has been quietly asserting its presence from the unfathomable darkness below. I'm not speaking of below the Earth, but beneath the entire orbital plane of our solar system itself. We call it BB. This isn't just another icy wanderer. BB is a cosmic leviathan approximately 140 kilometers across. To put that into scale, most comets that excite us are mere kilometers wide. BB could swallow dozens of them whole and still demand more. What makes BB even stranger is its origin and trajectory. Most objects within our solar system orbit the Sun on roughly the same flat plane like grooves on a cosmic vinyl record, but BB, it's plunging in at an inclination of about 95 degrees. Visualize all our planets spinning harmoniously on a table. Now picture a colossal cannonball erupting from underneath that table, tearing through at a near-perfect right angle. That's BB. It emerges from what amounts to a celestial blind spot, a region we seldom scrutinize because by all conventional wisdom, nothing of significance is supposed to be there. Now the plot thickens, and by thickens, I mean it enters the realm of the profoundly unsettling. At an astounding distance of 16.6 astronomical units from the Sun, that's 16 times Earth's distance, the Atacama Large Millimeter Submillimeter Array ALMA for short detected something utterly unexpected. Carbon monoxide actively venting into the vacuum of space from BB's frigid surface. At that distance, the sunlight reaching BB is a paltry 1/275th of what we experience on Earth. It should be a frozen, inert tomb, yet it's alive. Comets typically ignite with activity much closer to the Sun, usually within Jupiter's orbit. But BB is already puffing away far beyond the traditional snowline, where such behaviour is expected. This prompts a pivotal question one whispered in quiet scientific corridors. Why is it active so early? What force is rousing this ancient giant from its billion-year slumber? You might reasonably assume it's simply a massive comet doing predictably massive comet things. And perhaps it is. But consider the timing. As we speak in late 2025, we're witnessing not only BB's inexplicable awakening, but also the arrival of 3I Atlas, an interstellar guest, with its own bizarre characteristics. We're observing black holes flare with unimaginable brilliance, and discovering new moons around Uranus entities that somehow eluded us for centuries. The cosmos, it seems, is growing louder, more active, less predictable. What if BB isn't just a comet? What if this ancient colossal worldlet, this primeval relic from our solar system's birth, is responding to something far grander? What if its sudden awakening is the first tangible symptom of a profound energetic shift, a cosmic ripple coursing through the Sun's vast domain, a phenomenon we're only now beginning to perceive? I understand what you're thinking. This sounds like the opening act of a disaster movie, and perhaps it is. But these are not fictions. BB is real. Its outgassing is real. Its peculiar orbital geometry is real. And the inescapable fact that no one can definitively explain its premature activity at such a vast distance is very, very real. Over the coming parts, we will delve into the known facts about BB, its extraordinary size, its bizarre orbit, and why that orbit holds more significance than you might imagine. We'll then explore the multitude of theories, some firmly rooted in mainstream science, others venturing into less conventional territory, about what this object truly represents. We'll consider black swan risks, those low-probability, high-impact events that haunt the dreams of mission planners. We'll even dip into the esoteric corners of the internet where people ponder if BB is a harbinger of cosmic change. Finally, we'll zoom out to survey the broader celestial landscape, examining 3i Atlas and other recent anomalies that just might be interconnected. By the end, you'll be left with a choice to file this away as a fascinating but ultimately mundane astronomical curiosity, a very large comet exhibiting slightly odd behaviour, or to allow yourself a sliver of wonder to consider that we might be witnessing something far more momentous, that our solar system, after billions of years of relative tranquility, could be entering a new dynamic phase where the giants awaken. So let's begin with the fundamentals. What exactly is BB? Where did it come from? And why should a colossal ice ball, still years from its closest approach to the Sun, capture our attention? Because if the data holds, if the models are accurate, this entity is already transforming, already in motion, already awake, and it's emerging from a vector we never thought to observe. Let's talk numbers. BB's nucleus, the solid heart of this cosmic behemoth, is estimated at around 140 kilometers in diameter. Some measurements push that figure closer to 150 kilometers. For scale, this is roughly the size of a small moon, not much smaller than some of the minor satellites orbiting Saturn or Uranus. Place BB next to Comet Hale-Bopp, one of the most spectacular comets of the late 20th century, and Hale-Bopp would appear as a mere pebble beside a bowling ball. And Hale-Bopp was already considered enormous. But its sheer size isn't the only enigma. BB is profoundly dark. Its surface possesses an exceptionally low albedo, reflecting almost no sunlight. Scientists describe it as darker than coal, blacker than fresh asphalt. This isn't merely a cosmetic detail. A dark surface absorbs significantly more solar radiation. This implies that even at vast distances from the Sun, BB could be heating up more efficiently than a brighter object. This absorbed heat, however faint, could be sublimating ices beneath the surface, transforming solid material directly into gas, which then escapes to create the observed outgassing. The ALMA detection, which I mentioned earlier, warrants closer examination. ALMA, utilizing millimeter wave radio telescopes, observed BB and identified the JS21 rotational transition line of carbon monoxide at 230 GHz. In simpler terms, they precisely caught CO molecules spinning and emitting a specific wavelength of light unique to carbon monoxide. They also detected a dust continuum indicating that not only gas but also minor particles are being dragged along. This is the unmistakable signature of an active comet. Except again, BB was a staggering 16.6 AU from the Sun when this occurred. At that distance, conventional comet models predict virtually no activity. The Sun's embrace is simply too weak, and yet there it is, actively exhaling into the void like a colossal cosmic chimney. Now let's discuss its orbit, because this is where the narrative becomes cinematically bizarre. BB's perihelion, its closest approach to the Sun, is slated for January of 2031. At this point, it will be roughly 1095 astronomical units from the Sun, placing it just beyond the orbit of Saturn. So rest assured, BB poses no direct threat to Earth. This object will not collide with us. But that's not the crucial point. The crucial point is the geometry of its path. BB's orbit is inclined at approximately 95 degrees to the ecliptic. That means it's nearly perpendicular to the plane where almost all other planets, most comets and asteroids serenely orbit. BB is doing something entirely different. It's ascending from below, slicing through the solar system at a sharp right angle to the familiar planetary disk. Astronomers classify this as a retrograde orbit, or in some contexts, a near-polar orbit. Regardless of classification, it is profoundly unusual. Why does this matter? Because the solar system isn't an empty vacuum. It's permeated by the solar wind, a relentless torrent of charged particles streaming outwards from the sun. It's threaded with magnetic field lines spiraling outwards in a grand structure known as the Parker spiral. And it's organised around the heliospheric current sheet, a vast wavy boundary, where the sun's magnetic polarity flips from north to south. Most objects in our solar system spend their existence moving roughly parallel to this current sheet, gently undulating through it like a boat on a calm cosmic sea. But BB is going to punch through that current sheet almost perpendicularly, like a knife bisecting a layer cake. What happens when a massive outgassing object traverses strong magnetic boundaries at such steep angles? Frankly, we don't precisely know. Theories abound. Some scientists speculate it could trigger enhanced outgassing as magnetic fields interact with charged particles within BB's coma, the enveloping cloud of gas and dust. Others suggest it might induce powerful jet activity, focused streams of gas erupting from specific points on its surface. Still others maintain that nothing unusual will transpire, that BB will simply sail through geometry, be damned like any other comet. But here's the caveat: BB will cross the ecliptic plane in August of 2033. That moment marks its direct passage through the very orbital disk where all our planets reside. And at that juncture, it will interact with solar wind structures, magnetic fields and particle streams in ways no other observed comet of this magnitude has, simply because none have ever held such an orbit. Then there's the question of mass and gravity. At 140 kilometers across BB is far more than a loose agglomeration of rubble held together by feeble ice bonds. It possesses significant self-gravity, enough to maintain its coherence as an object. When gas escapes its surface, it doesn't simply dissipate into interstellar space. Some of it might actually fall back, forming a transient atmosphere or a persistent dense coma. This creates fascinating feedback loops. Gas escapes, some returns, heats the surface, causing more gas to escape. It's a dynamic process that smaller comets rarely experience, lacking the gravitational heft to recapture their own ejected material. Scientists have diligently run models attempting to forecast BB's activity as it approaches perihelion. Some models project a steady, predictable increase in brightness and outgassing. Others hint at the possibility of dramatic outbursts, sudden violent surges in activity that could potentially render BB visible to the naked eye. And then there are a few models, the ones that truly keep mission planners awake at night, which suggest the terrifying possibility of fragmentation. This is when a comet fractures, whether due to rotational stress, thermal stress, or the immense pressure of its own outgassing. Should BB fragment even partially, it would transform into an entirely different class of object, multiple pieces each, potentially active each on its own trajectory, each exponentially harder to track. So here we have our foundation, a colossal, dark, self-gravitating worldlet. It travels on a near-perpendicular orbit, actively outgassing far from the Sun, and is approaching a perihelion that will take it through regions of space where magnetic and particle interactions could dramatically amplify its behaviour in utterly unpredictable ways. This is not merely a comet. This is a monumental natural experiment in cometary physics, orbital mechanics and solar system dynamics, all rolled into one. And the cosmic clock is ticking. Perihelion is in 2031, the ecliptic crossing 2033. We have less than a decade to decipher what BB is, what it's doing, and what it might do next. Which brings us to the next profound question. What if this isn't simply physics as we understand it? What if there's a deeper narrative unfolding? Consider a thought experiment. Imagine you could pluck a piece of our solar system from 4.6 billion years ago, from the very moment planets were still coalescing and the Sun was a temperamental infant throwing fits of radiation. And then you froze it, locked it away in a cosmic deep freeze, untouched, unaltered, perfectly preserved. That in essence is what BB might be. A time capsule, a relic, a fossil from the genesis of everything we know. The Oort cloud, from which BB almost certainly originated, is a vast spherical shell of icy bodies encircling our solar system at distances ranging from thousands to hundreds of thousands of astronomical units. These objects formed early on closer to the Sun, but were gravitationally flung outwards by the dance of the nascent giant planets Jupiter, Neptune, Uranus, Saturn. Out there in the profound cold and perpetual dark, they have remained barely changed, barely warmed, simply waiting. BB was one of them. Until something, a passing star, a subtle gravitational nudge from a distant encounter, sent it hurtling back towards the Sun. Because BB has spent almost its entire existence so far from the Sun, it has likely retained ices that other comets lost eons ago. We're talking about ultra-volatile materials: carbon monoxide, carbon dioxide, nitrogen, methane, ammonia. These substances vaporize at exceptionally low temperatures, meaning they are the first to boil away when a comet approaches the Sun. Most comets we study are depleted in these primordial materials, having made countless journeys through the inner solar system, shedding a little more with each pass. But BB, this could be its inaugural journey inward in billions of years, its first true exposure to significant sunlight in eons. This implies its chemical composition could be utterly pristine. The ALMA detection of carbon monoxide is a powerful clue that BB is teeming with these primordial volatiles. Carbon monoxide is among the most volatile known, sublimating at around 68 Kelvin or 205 degrees Celsius. At BB's current distance, temperatures likely hover in that range, perhaps slightly warmer on the sun-facing side. So the active venting of CO suggests an abundant reservoir beneath the surface, eagerly awaiting release. Now let's consider the implications of an object this massive beginning to outgas. With smaller comets, gas and dust escape relatively easily. The comet's weak gravity offers little resistance and particles stream away, forming the iconic tail. But BB is different. Its gravity, though still far weaker than Earth's, is potent enough to retain some of the material it ejects. This gives rise to what some researchers term a supercoma, a thick, dense shell of gas and dust that hovers around the nucleus instead of rapidly dissipating. This supercoma significantly alters how we perceive the object. It scatters sunlight, making BB appear brighter than its nucleus alone would suggest. It can also create optical illusions, making the nucleus appear larger or more diffuse than its actual form. But there's a more menacing aspect to this process. If gas is erupting from beneath the surface yet partially trapped by BB's gravity, significant pressure can build. Imagine a pressure cooker, its lid almost, but not quite sealed. Pressure mounts heat, intensifies, and then suddenly the lid explodes. In cometry terms, this manifests as an outburst, a sudden, violent release of gas and dust that dramatically increases the object's brightness and activity. Outbursts are common among comets, but for an object as colossal as BB, an outburst could be breathtakingly spectacular and utterly unpredictable. So what precisely is triggering this activity in the first place? That indeed is the million-dollar question. At 16.6 AU sunlight alone should not be sufficient to drive such substantial sublimation. The energy input is simply too meagre. Consequently, scientists have proposed several alternative mechanisms. One possibility is internal heat. Radioactive decay of elements like aluminum-26 or potassium-40 could generate warmth from within, slowly heating the interior over geological timescales. However, for an object frozen for so long, it's unclear if enough radioactive material remains to make a significant difference. Another compelling possibility involves the crystallization of amorphous ice. When water ice forms rapidly in extremely cold conditions, it can be amorphous, its molecular structure disordered. Over vast periods, this amorphous ice can transition into crystalline ice, a process that inherently releases heat. If BB's interior harbours large quantities of amorphous ice, this crystallization could provide sufficient energy to drive the sublimation of more volatile materials like carbon monoxide. It's a slow burn, but over billions of years it compounds. then there are external factors. Cosmic rays, high-energy particles from outside our solar system, relentlessly bombard objects in space. When they strike ice, they deposit energy, causing localized heating and sublimation. At great distances from the Sun, where solar heating is negligible, cosmic rays might be the primary catalyst for activity. Some models suggest that BB's early outgassing could be almost entirely powered by this cosmic ray bombardment, at least until it ventures closer to the Sun and solar heating inevitably takes over. We also cannot ignore the magnetic field dynamic. As BB traverses the solar system, it moves through the Sun's expansive magnetic field, which stretches far beyond the planets. This field is not uniform. It is structured dynamic, punctuated by current sheets, shockwaves, and turbulent regions. When a massive conducting object like BB, its coma filled with charged particles, moves through these intricate magnetic structures, it can experience forces and heating effects that smaller, less active objects would not. Some researchers have speculated that magnetic reconnection events where field lines abruptly snap and release stored energy could occur within BB's coma, directly depositing heat into the gas and dust. All of this converges on a fundamental challenging question. Is BB merely waking up because it's finally within sufficient proximity for its ancient ices to respond to the Sun's faint warmth? Or is something else at play? Is the heliospheric environment itself undergoing a transformation, becoming more energetic, more active in ways we are yet to fully comprehend? Could BB's awakening be less about BB itself and more about the ever-changing cosmic currents it navigates? That's a question we will revisit. But for now, let's acknowledge the tantalizing possibility this is not a simple comet performing simple cometary deeds. This is a primordial giant, a frozen world from the very birth of our solar system, stirring from a sleep that has lasted for billions of years. And the fact that it is doing so now in our lifetimes, at a moment when other strange phenomena are unfolding across the cosmos, is either a profound coincidence or a crucial clue. The data remains undecided, and so should we. Now let's confront the possibilities of things going spectacularly wrong. Not wrong in the sense of BB careening towards Earth. That scenario thankfully is not on the table. Rather wrong in the context of BB behaving in ways that utterly defy our models, our predictions, our deeply held understanding of how colossal comets are supposed to function. In the lexicon of risk analysis, such events are termed black swans. Rare, wholly unexpected, high-impact occurrences that no one foresaw because existing models simply couldn't account for them. And where BB is concerned, the black swans are beginning to circle. Start with non-gravitational forces. When a comet outgasses, it's not merely releasing gas into space, it's generating thrust acting like a minuscule natural rocket engine. Gas molecules escaping from the surface carry momentum, and by Newton's third law, the comet itself experiences a reaction force in the opposite direction. For smaller comets, this effect is well documented. It can subtly alter the comet's rotation, its spin axis, and even its long-term trajectory. But for an object as gargantuan as BB, the calculations become far more complex. How much thrust can a 140-kilometre worldlet generate? How is that thrust distributed across its vast rugged surface? And what if the outgassing isn't uniform? If BB develops concentrated active regions, those spots would act like directional thrusters. Over weeks, months or years, they could torque the entire object, dramatically altering its spin. They could accelerate it along its orbit, causing it to arrive at perihelion slightly earlier or later than predicted. They could even subtly nudge its trajectory enough to shift its closest approach distance by thousands or tens of thousands of kilometers. That might sound negligible, but in the intricate ballet of orbital mechanics, even small changes compound. And if we envision any future spacecraft mission to BB, as some scientists have proposed, getting the trajectory wrong could mean missing it entirely. Then there is the chilling outburst scenario. Comets are notorious for sudden dramatic surges in brightness and activity, sometimes increasing several magnitudes in mere hours or days. These outbursts are thought to result from the exposure of fresh, volatile rich material, perhaps from landslides, deep fissures, or the sudden blow-off of an insulating dust layer. For BB, an outburst could be nothing short of spectacular. Imagine a section of its colossal surface, perhaps several kilometers across, suddenly erupting with high-velocity gas. The coma would brighten intensely, dust production would spike, and observers on Earth would witness a profound transformation in BB's appearance, potentially even with the naked eye. But there's an even darker possibility. What if an outburst is violent enough to literally fracture the nucleus? Fragmentation is the ultimate nightmare scenario. Comets do break apart. We've witnessed it before. Comet Shoemaker-Levy 9 famously fragmented into over 20 pieces before its catastrophic collision with Jupiter in 1994. Comet 73P Schwarzmann-Wachmann 3 disintegrated into dozens of fragments in the early 2000s. When a comet fragments, its total surface area dramatically increases, which further accelerates sublimation and makes the individual fragments even more active. For BB, fragmentation would transform it from a single trackable entity into a swarm of smaller bodies, each pursuing its own trajectory, each potentially hazardous to any spacecraft attempting to study it, each adding layers of complexity to an already intricate situation. What forces could cause BB to fragment? Several possibilities exist. Rotational stress is one if BB is spinning, and that spin rate increases due to outgassing. The immense centrifugal force could eventually overwhelm the object's structural integrity, pulling it apart at the equator. Thermal stress is another. Uneven heating from the sun could create extreme temperature gradients, causing the surface to crack and buckle. And then there's the sheer pressure of outgassing itself. If gas accumulates beneath the surface faster than it can escape, the internal pressure could literally blast chunks of the nucleus off into space. Observationally, scientists are vigilant for warning signs, changes in BB's brightness that deviate from predicted models, asymmetries in the coma that hint at localized jets or active regions, or non-gravitational accelerations appearing as subtle deviations from its predicted orbit. All these would signal that BB is not merely a simple inert rock passively falling towards the sun. They would suggest something far more dynamic, more energetic, more unpredictable. From a mission planning perspective, all these variables matter enormously. Several research groups have already proposed sending a spacecraft to BB. The concept is incredibly compelling. Intercept it around perihelion, study it up close, perhaps even land a probe on its surface, and collect pristine samples of primordial material frozen since the very genesis of our solar system. Such a mission would be among the most scientifically valuable ever undertaken, but it is also fraught with risk. Launch windows are incredibly narrow. If BB's trajectory subtly shifts due to non-gravitational forces, the mission could fail before it even arrives. And if BB fragments navigating through a debris field becomes exponentially more challenging. There's also the profound question of what we do with the data. If BB performs something truly unexpected, something that simply doesn't fit existing cometary models, we need to understand why. Is it because BB is fundamentally different from other comets we've studied? Or is it because the environment it is moving through, the heliosphere, the magnetic field, the solar wind, is different from what we thought? Either answer carries immense implications. The first enlightens us about the sheer diversity of solar system bodies. The second reveals insights into the changing nature of the solar system itself. And then there's the public perception. If BB experiences a major outburst and suddenly becomes visible to the naked eye, people will undoubtedly notice. They will demand answers. And if those answers involve scientific uncertainty, if scientists must acknowledge, we're not entirely sure why this is happening, that ambiguity creates a vacuum ripe for speculation. Some of it will be scientifically grounded, some less so, and some of it, as we will explore shortly, will inevitably veer into the realms of the esoteric and the conspiratorial. So here we stand, a massive ancient outgassing worldlet, on an anomalous orbit hurtling towards a perihelion, where its behavior could become profoundly nonlinear. We have credible scenarios for outburst fragmentation and trajectory shifts that could transform BB into an object far more dynamic than anyone anticipated, and we have a painfully limited window of time to study it before it recedes into the outer solar system, disappearing for another few million years. The stakes are immense, the risks palpable, and the cosmic clock as ever relentlessly ticks onward. But before we fully immerse ourselves in mission planning and orbital mechanics, we must address the colossal elephant in the room, or rather the worldlet in the outer solar system. Because for every diligent scientist meticulously analysing BB's spectral lines and orbital elements, there's another voice, perhaps quieter, asking a fundamentally different question. What if this isn't random? What if BB's awakening carries a deeper meaning? Let's momentarily step outside the confines of the laboratory. Let's leave behind the spectroscopy, the orbital equations, and the carefully calibrated language of peer-reviewed papers. Let's listen to what people are saying in other corners of the internet, in forums, chat rooms, and the comment sections of YouTube, where the discourse around BB takes on a dramatically different tone. To some, BB is more than just a comet. It is a symbol, an omen, a cosmic harbinger. The very fact that it approaches from beneath the solar system, from a direction we rarely scrutinise, resonates with ancient archetypal narratives, the return of the repressed, the shadow rising, the hidden thing finally coming to light. In countless mythologies, gods and monsters alike emerge from the underworld, from beneath the earth, from the dark, forgotten places. And now, here comes BB, a giant worldlet from the cosmic underworld of the Oort cloud, stirring from a billion-year sleep and inexorably moving towards the sun. The timing too feels profoundly significant to many. BB's awakening coincides not only with the arrival of 3i Atlas, an interstellar visitor with its own suite of anomalies, but also with increased solar activity as the sun approaches solar maximum in its 11-year cycle. It aligns with the stunning discoveries of new moons, the awe-inspiring flares of black holes, and revelations about dark matter that are challenging our cosmological models. To a certain mindset, these are not mere coincidences. They are synchronicities, meaningful patterns emerging from apparent chaos signs that something monumental is shifting. What could this shift entail? Some propose that our solar system is traversing a new region of the galaxy, a zone characterized by higher cosmic ray flux, more potent magnetic fields, or a denser interstellar medium. This, they argue, could be triggering the increased activity we observe in distant objects like BB. The heliosphere, the protective bubble of solar wind that envelops our solar system, is in constant dynamic interaction with the interstellar medium. If that medium changes, the heliosphere changes. And if the heliosphere changes, objects within it, especially large sensitive bodies like BB, might very well respond. Others push this concept further. They suggest that BB isn't merely responding to external stimuli, but is itself a kind of energetic antenna, a massive reservoir of primordial material now releasing energy into the solar system. They draw parallels to ancient texts, mythologies, and prophecies that speak of cosmic cycles of new epochs and beginnings of celestial events marking profound transitions. In this perspective, BB becomes the physical manifestation of a metaphysical shift, a cosmic signal that humanity is moving from one cosmic age to another. Now, before we dismiss these interpretations entirely, let's be unequivocally clear: the overwhelming majority of scientists who study BB view it as a natural object, behaving in accordance with known physical laws. There is no credible evidence suggesting BB is anything other than an exceptionally large comet. Its composition, as far as we can discern, is consistent with natural ices and rock. Its behaviour aligns with cometary physics. Its orbit is consistent with Oort cloud dynamics. Coincidences are a fundamental aspect of a vast universe where rare events occurred simply because there are so many opportunities for them to transpire. However, science also teaches us the invaluable lesson of humility. To acknowledge that our models are approximations, that our understanding is perpetually incomplete, and that the universe is under no obligation to conform to our expectations. And while the conspiratorial and esoteric interpretations of BB may lack empirical support, they nonetheless raise questions worthy of consideration. What if there are large-scale energetic phenomena we don't yet grasp? What if the solar system's environment is more dynamic, more responsive than we've assumed? What if objects like BB are in fact incredibly sensitive indicators of changes we haven't yet learned to measure? There's also the question of what BB represents philosophically. For most of human history, we clung to the belief that the heavens were static, immutable, eternal. Then we discovered that stars evolve and die, that galaxies collide, that the universe itself is in a state of perpetual expansion. We learned that change, not stasis, is the cosmic norm, yet we still tend to view our own solar system as stable, predictable, and safe. BB challenges that deeply ingrained perception. Here is an object that has been invisible, unknown, and utterly irrelevant for the entirety of human civilization. And now, suddenly it is active. It is here. It is doing things. It serves as a stark reminder that even in our own cosmic backyard, there are giants we don't know about, processes we don't fully understand, and events we cannot predict. Some take this further, asking if BB is waking up now, could other objects be stirring as well? The Oort cloud is theorized to contain trillions of icy bodies. What if BB is merely the first one we've noticed? What if there's an entire cohort of giant worldlets all beginning to awaken, all responding to some subtle, overarching shift in the solar environment? It's a speculative idea, but not an impossible one. And if true, it would imply that the solar system is entering a more active phase, a period of increased cometary flux, more impacts, more close encounters, more opportunities for discovery, and yes, more inherent risks. Then there's the fringe idea that BB might not be entirely natural. I must tread very carefully here, as this is precisely where such conversations often derail. Some individuals have speculated that exceptionally large, highly unusual objects in space could be artificially constructed, or at the very least artificially modified. This notion gained significant traction with Oumuamua, the first confirmed interstellar object, which possessed an elongated shape and exhibited non-gravitational acceleration that some argued couldn't be solely explained by outgassing. Subsequent more robust analysis suggested that outgassing could in fact explain Oumuamua's behaviour, and the scientific consensus remains that it was a natural object. But the speculation persists. For BB, however, there is absolutely no credible basis for an artificial origin hypothesis. Its chemical composition, as best we can tell, is entirely consistent with natural ices and rock. Its observed behaviour aligns perfectly with cometary physics. Its orbit is consistent with established Oort cloud dynamics. But the very fact that people even pose such a question reveals something profoundly human. We yearn for the universe to surprise us. We long to discover that we are not alone, that other intelligences exist, that the cosmos is more than just inert rocks, gas and radiation. And large, unusual objects like BB become vast screens onto which we project those deepest hopes and fears. So where does this leave us, with a broad spectrum of interpretations ranging from the rigorously scientific to the wildly speculative? Scientists observe a fascinating, albeit natural phenomenon. Esotericists perceive a cosmic signal. The conspiratorially minded detect a cover-up or a hidden truth, and most people frankly are unsure what to believe. They see the images, read the headlines and wonder, is this something I should truly be paying attention to? Does this actually matter? The answer, I believe, hinges on your definition of matters. Will BB directly impact your daily life? Almost certainly not. It will not crash into Earth. It will not blot out the sun. It will not trigger earthquakes or cataclysmic storms, nor any of the apocalyptic scenarios that occasionally propagate online. But will it reveal something profoundly important about our solar system, about its formation, its evolution, its ongoing transformations? Absolutely. And that unequivocally matters. Because the more deeply we comprehend the cosmos, the better equipped we are to inhabit it, to navigate its wonders, and perhaps one day to explore it far beyond the confines of our own small planet. With that perspective, it's time to zoom out to consider BB not in isolation, but as a component of a much larger cosmic tapestry. Because BB is not the only unusual object currently captivating our attention. There is another visitor, another anomaly, another puzzle, and its name is 3I Atlas. While BB has been quietly outgassing in the frigid reaches of the outer solar system, another object has truly seized the celestial spotlight. Its official designation is C2025N1, but it is more famously known as 3I Atlas, the third confirmed interstellar object to journey through our solar system. Unlike BB, which is gravitationally bound to the Sun and will eventually recede only to return in a few million years, 3I Atlas is merely passing through. It originated from elsewhere from another star system entirely, and it is now on its hyperbolic trajectory out never to return. The discovery of 3I Atlas was a monumental event. Following Oumuamua in 2017 and 2I Borisov in 2019, astronomers had been eagerly scanning the heavens for the next interstellar voyager. When 3I Atlas appeared in early 2025, telescopes worldwide immediately locked onto it, and what they found was utterly baffling. Let's begin with its chemistry. The James Webb Space Telescope JWST obtained infrared spectra of 3I Atlas and detected something extraordinary, a coma overwhelmingly dominated by carbon dioxide. Not water vapour, which is the primary volatile in most comets, not carbon monoxide, which is common in some, but carbon dioxide. The CO2 to H2O mixing ratio was measured at approximately 8:1, meaning for every molecule of water vapour, there were 8 molecules of carbon dioxide. This makes 3I Atlas one of the most CO2-rich comets ever observed. Why is this significant? Because the relative abundances of volatiles in a comet provide crucial clues about where and how it formed. In our solar system, most comets originated in the region between Jupiter and Neptune, where water ice was abundant. But 3I Atlas likely formed around a different star, possibly one with lower metallicity, fewer heavy elements, which would favour the formation of carbon-rich ices over water ice. In essence, 3I Atlas offers us a rare glimpse into the primordial chemistry of another planetary system, a system potentially very different from our own. Then there's the polarimetry. When sunlight scatters off dust particles, it becomes polarised, and the degree and direction of that polarisation are dictated by the size, shape, and composition of those particles. Observers measured the polarisation of sunlight reflected off 3I Atlas, and uncovered another anomaly, a negative polarisation branch, meaning the polarisation actually decreased at certain angles, instead of increasing as expected. This signature is exceptionally rare. It's typically seen in objects with very dark carbon-rich surfaces like trans-Neptunian objects or centaurs, but almost never in typical comets. This strongly suggests that 3I Atlas might possess a surface composition more akin to distant primitive solar system bodies than to the brighter icy comets we're accustomed to studying. Finally, radio observations detected hydroxyl OH radicals within the coma of 3I Atlas. Hydroxyl is a byproduct of water molecules breaking down under ultraviolet sunlight. Its presence unequivocally confirms that 3I Atlas is active, that it is outgassing, and therefore it is not merely an inert rock tumbling through space. This in turn helps to solidify its status as a natural object, dispelling any lingering questions of an artificial probe, a query that famously arose with Oumuamua. So here we have them, two extraordinary objects, BB and 3I Atlas. Both are undeniably active, both highly unusual, and both capturing intense scientific attention in 2025. Yet they are profoundly different. BB is colossal, 140 kilometers across. 3I Atlas is small, roughly 11 kilometers in diameter. BB is bound to our Sun, tracing an elliptical orbit that spans millions of years. 3I Atlas is on a hyperbolic trajectory, moving at immense velocity, already on its outbound journey from our solar system. BB likely formed in our solar system's own Oort cloud. 3I Atlas originated around a distant star, perhaps light years away, and was gravitationally ejected into interstellar space, before drifting through the cosmic void until it chanced upon our neighbourhood. Yet despite these striking differences, there's something deeply compelling about considering them together. Both are primitive bodies, invaluable relics from the early epochs of planetary formation, whether in our system or another. Both are unveiling chemistries that directly challenge our long-held assumptions. Both are demonstrating activity at unexpected distances or in unexpected ways. And crucially, both are here in our skies at precisely the same moment in time. Is this truly meaningful? From a purely statistical standpoint, probably not. The rate of interstellar object discoveries has increased simply because our survey telescopes have become exponentially more powerful and systematic. We are finding more asteroids, more comets, more of everything because we are looking harder and more thoroughly. The fact that 3I Atlas appeared while BB is approaching perihelion is likely just a cosmic coincidence, a stroke of timing. The universe is vast and myriad things happen. But let's indulge the idea for a moment. What if there is a connection, not a direct causal link but an environmental one? What if both objects are responding to current conditions within the heliosphere that are right now uniquely conducive to cometary activity? What if the solar wind is more potent, or the magnetic field more turbulent, or the cosmic ray flux unusually high? And what if these conditions are triggering outgassing in objects that would otherwise remain dormant? There is some historical precedent for this line of thinking. Our solar system does not exist in splendid isolation. It is hurtling through the galaxy at roughly 220 kilometers per second. And as it moves, it inevitably encounters different regions of interstellar space. The density of the interstellar medium, the strength of the interstellar magnetic field, the flux of cosmic rays, all these parameters fluctuate depending on our galactic location, and all of them can in principle affect the heliosphere and the objects nestled within it. Some researchers have theorized that the solar system periodically passes through denser regions of the interstellar medium, and that these passages could precipitate increased cometary activity. The hypothesis suggests that a denser medium compresses the heliosphere, altering the pressure balance at its boundary. This change then propagates inward, influencing the solar wind, the magnetic field, and ultimately the comets themselves. It's a speculative idea, and the direct evidence for it remains circumstantial at best, but it is not outlandish. It is founded on real physics, even if the precise details remain murky. If something akin to this were transpiring now, if the heliosphere were undergoing some subtle yet profound shift, you might expect to observe precisely what we are witnessing. Increased activity in distant comets like BB, and an uptick in the discovery rate of interstellar objects like 3I Atlas, which might become more detectable when the heliosphere is disturbed due to stronger interactions with the solar wind, or perhaps it's far simpler than that. Perhaps we're simply in a period of astronomical good fortune. We built the James Webb Space Telescope. We meticulously upgraded our ground-based observatories. We launched innovative survey missions, and now we are reaping the rich rewards in the form of breathtaking discoveries. BB was always destined to awaken as it journeyed towards the sun. 3I Atlas was always fated to pass through our cosmic neighborhood. We simply happened to be watching at the opportune moment, armed with the right tools. Regardless, the comparative study of BB and 3I Atlas is immensely instructive. They represent two divergent ends of a profound spectrum. BB is the insider, the homegrown giant, the primordial relic from our own solar system's distant past. 3I Atlas is the quintessential outsider, the transient traveller, a silent messenger from an entirely different world. Together they encapsulate the breathtaking diversity of icy bodies that populate our universe. And together they serve as a powerful reminder that our solar system is not a closed insulated box. Material flows in from interstellar space. Material flows out. We are an integral part of a larger galactic ecosystem, and events here are intimately connected, however tenuously, to events unfolding everywhere else. This brings us to the final crucial piece of the puzzle. Because BB and 3I Atlas are not the only unusual phenomena gracing the cosmos in 2025, the universe has been exceptionally busy, and if we truly wish to discern whether BB's awakening is an isolated incident, or part of a broader, more significant pattern, we must examine the other cosmic shocks that have recently captured headlines. Flares, discoveries, revelations, all pointing to a universe far more dynamic than we sometimes afford it credit for. Let's zoom out one final time. Let's step back from the intricate dance of comets and orbits and cast our gaze upon the grand cosmic tableau, the astonishing celestial events of 2025 that have left astronomers both exhilarated and perhaps a little unnerved. Because if you've been paying attention to science news this year, you've likely discerned a recurring theme: the universe consistently surprises us. And not in minor ways, but in major headline-grabbing, paradigm-challenging ways. Begin with the black hole superflare. In November of 2025, astronomers using cutting-edge X-ray telescopes detected an unprecedented flare erupting from a supermassive black hole nestled at the heart of a distant galaxy. This was no ordinary flare. It was one of the brightest ever recorded radiating luminosity equivalent to roughly 10 trillion suns. For a brief astonishing period, that single black hole outshone its entire host galaxy by orders of magnitude. The flare was attributed to a tidal disruption event where a hapless star wandered too close to the black hole's insatiable maw and was violently torn apart by gravitational forces. The shredded stellar material then spiraled into the black hole, unleashing an unimaginable torrent of energy in the process. While tidal disruption events are known, this one was exceptional in its brilliance and duration. It is compelling astronomers to fundamentally reconsider existing models of black hole accretion, of how matter falls into black holes and the staggering amounts of energy that can be released. And it serves as a stark reminder that even on the grandest scales, at the cores of galaxies millions of light years away, the universe is a violent dynamic arena capable of sudden dramatic transformations. Closer to home, the James Webb Space Telescope may have achieved another remarkable feat: the discovery of a new moon orbiting Uranus. Designated S2025-U1, this tiny world is only about 10 kilometers across, ironically roughly the size of 3I Atlas. It is faint, exceptionally difficult to observe, and its existence might not even be officially confirmed for months or years, as astronomers meticulously refine its orbit. But if validated, it raises a compelling question. How did we miss it for so long? Uranus has been studied for centuries. Voyager 2 flew past it in 1986. Ground-based telescopes have observed it for decades. And yet here is a moon, an entire world that somehow eluded our grasp. The likely answer is a humbling one: space is vastly larger and infinitely darker than we often care to admit. Even within our own solar system, even around planets we believe we understand intimately, there are countless hiding places. Small dark objects can evade detection for extraordinarily long periods, and this has profound implications. If we are still unearthing 10-kilometer moons around Uranus, what else remains undiscovered? How many other objects in the outer solar system or even closer remain hidden, simply because they are faint or dark or positioned in the wrong place at the wrong time? Then there is the Euclid Space Telescope, the European Space Agency's ambitious mission to meticulously map the distribution of dark matter and dark energy across the observable universe. In 2025, Euclid unveiled its initial major data products: breathtakingly detailed maps of millions of galaxies, precise measurements of gravitational lensing, and refined constraints on cosmological parameters. The initial results are both confirmatory and profoundly challenging. They largely confirm the foundational lambda CDM model of cosmology, the prevailing idea that our universe is predominantly composed of dark energy and dark matter, with ordinary matter constituting only a small fraction. But they also hint at persistent tensions, subtle discrepancies between different measurements that might indicate something is fundamentally amiss with our current understanding. These tensions have been simmering for years. The Hubble constant, the rate at which the universe is expanding, appears to yield different values depending on the measurement technique employed. The clumpiness of matter in the universe, quantified by a parameter known as sigma 8, also exhibits perplexing discrepancies. Euclid's new data is adding significant fuel to these scientific debates, suggesting that either our measurements are systematically flawed, which is always a possibility, or there is entirely new physics at play which would be nothing short of revolutionary. Why does this broader cosmic context matter for BB? Because it underscores a larger overarching theme. The universe is not static, not fully understood, nor entirely predictable in all its myriad details. We often prefer to believe we have the grand cosmic picture largely figured out. We comprehend how stars form, how galaxies evolve, how planets orbit, but it is in the details, the edges, the outliers, that the most profound surprises invariably reside. And 2025 has been a year overflowing with such surprises. There's also the ongoing strangeness surrounding solar activity. Our sun is inexorably approaching solar maximum, the peak of its 11-year cycle, and it has been far more active than predicted. More sunspots, more powerful flares, more frequent coronal mass ejections. While some of this is simply normal variability, solar cycles are never identical, there's a persistent nagging sense among some solar physicists that this current cycle feels different, stronger, more erratic, more potent. Whether that feeling stems from a genuine shift or simply an observational bias is difficult to ascertain definitively. The sun does not come with an instruction manual. We are still fundamentally learning how it works. Synthesize all these disparate phenomena, and you paint a picture of a cosmos in undeniable flux, black holes flaring to record brightness. Previously hidden moons revealing themselves around ancient planets. Dark energy measurements revealing subtle cracks in our most cherished theories. The sun acting up. Interstellar objects arriving with strange alien chemistry. And a colossal ancient worldlet awakening in the farthest reaches of our own solar system. Any one of these events viewed in isolation is fascinating but not necessarily alarming. It's simply science unfolding the universe, performing its intricate dance, researchers updating their models. But taken collectively, they begin to form a pattern, or at least the compelling suggestion of one. A pervasive sense that something is shifting, that the cosmic background we take for granted is becoming a little less stable, a little more surprising. Does this imply we're entering a new cosmic era, some kind of overarching energetic transition that is affecting everything from distant comets to entire galaxies? Probably not. The universe is in a constant state of surprising us, precisely because the universe is so vast and our understanding is always evolving. Every new telescope, every groundbreaking mission reveals phenomena we never previously imagined. That is the very essence of scientific progress. We acknowledge we don't know everything, so we relentlessly keep looking and we keep finding. But there's also a part of me, and perhaps a part of you, that can't help but wonder, what if there is something to this? What if our solar system is indeed traversing a region of space that is more energetically active? What if the galaxy is undergoing a phase that increases cosmic ray flux, or the frequency of interstellar object encounters, or the likelihood of cometary perturbations? What if BB's awakening is not merely about BB itself, but about the profound environment it is navigating? Here's the fundamental truth about cosmic change. It unfolds on timescales that our human intuition struggles to grasp. Our solar system takes a staggering 230 million years to complete a single orbit around the galactic center. The sun's position within the galaxy shifts glacially, slowly moving through different spiral arms regions of varying interstellar medium density and fluctuating magnetic field strengths. On human timescales, these immense changes are utterly invisible, but on astronomical timescales they are profoundly significant and they carry undeniable consequences. For instance, there's a compelling hypothesis that our solar system periodically passes through the galactic plane, the densest part of the Milky Way's disk, and that these passages correlate with periods of mass extinctions on Earth. The theory posits that traversing the galactic plane increases the flux of comets from the Oort cloud, which in turn increases the rate of impact on our planet, occasionally triggering catastrophic events. The direct evidence for this is vigorously debated, and the exact timescales don't always align perfectly, but the basic mechanism is plausible. the galactic environment profoundly affects solar system dynamics, which in turn affects life on Earth. We might be living through one of those subtle transitions right now, not on a catastrophic scale, not in a way that threatens civilization, but in a more nuanced manner, a way that increases the number of intriguing objects we encounter, the frequency of unusual celestial events, the pervasive sense that the cosmos is indeed waking up. And if that is true, if we are truly in a more active cosmic phase, then BB is not merely an anomaly. It is a herald, the first visible sign of something far, far larger. Or perhaps I'm simply overthinking this. Perhaps BB is just an exceptionally large comet doing what exceptionally large comets occasionally do. Perhaps 3i Atlas is just a random interstellar traveller, one of countless billions. Perhaps the black hole flare the new Uranus moon, the Euclid tensions, the heightened solar activity. Perhaps all of it is simply coincidence, the normal background hum of an inherently dynamic universe. Perhaps we are merely pattern-seeking creatures inherently wired to seek meaning in cosmic noise. But here is what we know with absolute certainty: BB is real. It is out there right now, roughly 16 astronomical units from the Sun, and steadily closing. It is outgassing. It is active. It is massive. And it is approaching from a direction we don't usually watch, on an orbit we rarely ever see at a time when other profoundly strange things are unfolding across the cosmos. Whether that confluence is meaningful or not, we're about to find out. Perihelion is in 2031, the ecliptic crossing 2033. We have less than a decade to watch, to measure, to understand, and perhaps, just perhaps, to send a mission. Because if BB truly is a primordial time capsule, if it genuinely holds pristine ices and organic compounds from the very birth of our solar system, then studying it up close could unlock answers to questions humanity has been asking for centuries. Where did we come from? How did the solar system form? What materials were present at the beginning? Are we alone? These are monumental questions, questions worth chasing, questions worth risking a spacecraft for. And if BB does something entirely unexpected along the way, if it fragments or experiences violent outbursts or shifts its trajectory in unforeseen ways, well, that's simply more data, more precious information, more intricate pieces to add to the cosmic puzzle. So as we draw to a close, I leave you with this thought: look up. Not metaphorically, but literally. Step outside on a clear night and gaze at the vast tapestry of stars. Somewhere out there, far beyond Saturn, far beyond the reach of most telescopes, a giant worldlet is falling towards the Sun. It has been falling for thousands of years, and it will continue its long descent for thousands more. You cannot see it with your naked eyes. You probably never will. But it is there, and it is changing. And whether that change is ordinary or extraordinary, whether it is pure physics or a whisper of prophecy, we're about to discover. Our solar system is far from finished surprising us. BB is undeniable proof of that. And whatever comes next, whether it is a quiet perihelion passage or something far more dramatic, we will be watching. Because that is what we do. We watch, we wonder, we wait. And when the universe finally deigns to reveal its secrets, we will be ready to listen. The giant is awake, the clock is ticking, and the show is about to begin.